So let's refresh our memories. The matrix has columns 2, 1, 0, 1, 2, 0, and 1, 0, 2. Okay, so 2, 1, 0. So look at this matrix with first column 2, 1, 0, second column 1, 2, 0, last column 1, 0, 2. So there is a way in Sage Math to also enter, to create matrices by first declaring or first defining the columns. Okay, so you can use this command called vector. Vector is a command that has parentheses, and inside the parentheses you have to specify the entries of the column vector as a list. The list has to be enclosed by square brackets. So this is not too complicated, but I'm just mentioning these details because they are syntax. Okay, so there's a command vector. You specify the entries of the column enclosed by square brackets separated by commas. The first column has values 2, 1, 0. They're separated by commas, but they are also enclosed by square brackets. Similarly, for the second column, you have numbers 1, 2, and 0, and the last column 1, 0, and 2. All of them were defined with the command vector. Each of those is stored in a variable that I chose to name this A1, A2. You can name it whatever you like. And then, instead of using the command matrix, which is what we had previously seen, you could use the command column underscore matrix. Column underscore matrix, you always have to use parentheses and also have to use square brackets. And then inside the square brackets, you list the columns. Okay, so for example, I'm going to, just for the sake of demo, you want to take a picture of this? Wait, don't take photos yet. Remember, this is being recorded, so you can also go back and, but if you want to take a photo, how can I stop you? Okay, so I'm going to delete this, or better yet, I'm going to comment it. So if I comment this, I comment A3, and I run this, I'm going to get an error. What? No error? That's the error, see? Error. And it's because it's complaining, let's see, error, traceback, blah, blah. Here, A3 is not defined. It's complaining because when I use that, what do you call this sign? Hashtag. There was a panda bear called hashtag in the Tonight Show. You're maybe, yeah. So anyway, hashtag. Hashtag in this is Python. If you know Python, if you don't, doesn't matter. Here, if you want to ignore, you want the code to be ignored, you type hashtag in front of it, and then everything, that line will be completely ignored by this computer algebra program. So it doesn't like that here there is something called A3, which it doesn't recognize. So I'm going to omit that from there. And you see, this creates a matrix with 2 columns. Now, what happens if I try to compute the eigenvalues of a matrix that has 2 columns and 3 rows? What happens? The eigenvalues rely on the calculation of the determinant. The determinant is only defined for square matrices. So if I try to use this command here, since that matrix A is now a 3 by 2, if I execute this here, I'm going to get one of those, see, the error there again, okay? So I'm going to put back A3. And I will execute this again. So now I confirm. This command show displays the matrix. If you don't want to do show, you could simply type the name of the variable that you create a matrix with the command column underscore matrix. That's, in this case, is A. If you type that variable again, it's going to display the numbers stored on that variable. Here is doing both, because I'm also having the command show. And now when I use these eigenvectors right, then there's no complaints. And so look at here. The eigenvectors always appear, so there's some kind of weird notation here because there is a parenthesis, and then there is a square bracket, and then there is a parenthesis closing over there. So what you want to pay attention here is the parenthesis and the first value that appears listed there, right? So we know the eigenvalues are 3, 2, they were 1, 2, and 3, basically. That's what they were. We called them in a different order, but we knew 3, 2, and 1, okay? So this here is the eigenvalue, and then there is a list separated by commas between parentheses. That's a vector, and that would be the vector associated with that eigenvalue. So the eigenvalue 3 has eigenvector 1, 1, 0. Then there is another number. If you're a former linear algebra student, that number is called multiplicity. If you've never seen this, don't worry. Don't worry about the multiplicity. So then you move on to the next. So there is that parenthesis, that number. That would be the next eigenvalue. And then there is a list of 3 values between parentheses. That would be the eigenvector associated with the eigenvalue 2. So you have a vector 0, 1, minus 1 associated with 2. And that has multiplicity 1. And then the last eigenvalue is 1. And it has eigenvector 1, minus 1, 0. Okay, so this is one way of, and since we had done some hand calculation for the eigenvalues, this is one way in which you can obtain the eigenvectors with the command dot eigenvectors underscore right, and then you have to leave the parentheses empty over there. Okay. This gives you the eigenvectors, but you have to be aware that the output there is a little messy with parentheses and value here and something or other, right? So, okay. Now I'm gonna give you in 4 minutes. That's good. In 4 minutes, I'm gonna give you another example that we're gonna do super quickly. So here is a system dx1 dt, dx2 dt. The first equation is x1 plus 2x2. The second equation is minus 2x1 plus x2. Excuse me. So what we like to do here is to write the general solution. So we can write this in matrix vector notation. The matrix has first column 1, minus 2, second column 2, 1. The eigenvalues and eigenvectors. We need the eigenvalues and eigenvectors for this. So this matrix, this matrix is the matrix defined in this example here. This is matrix with column 1, minus 2, and second column 2, 1, right? We confirm that. 1, minus 2, the first column, 2, 1, the second column. The eigenvalues are 1 minus 2i and 1 plus 2i. So here we have that lambda 1 is 1 minus 2i, and lambda 2 is 1 plus 2i. These are the eigenvalues. The eigenvectors, using that command eigenvectors right. So here's the eigenvalue 1 minus 2i, and here is a vector with 2 entries listed. First entry is 1, and the second entry is minus I. So I'm going to write that. So here, V1 is 1, minus I. The next one is 1 plus 2I, and the eigenvector is 1, comma, positive I. So this here, V2, would be 1, comma, positive I. So given that these are lambda 1, V1, and lambda 2, V2, what we need to do is to compute, right? We need to compute e to the lambda 1t, V1, plus e to the lambda 2t, V2, and this would be the solution, x of t. Still need here C1 and C2. Interestingly, each of these lambdas has non-zero real part and non-zero imaginary part, so each of those lambdas will require us to use Euler's equation. So when we say e to the lambda 1t, we're going to have to, we end up with cosine of 2t plus I sine of 2t and so on. They get interesting rather fast.